All right, natural log integration.
Oh, fun.
All right, so you got to remember the derivatives. I mean, when I teach these, I typically teach them so that they go back to back. So there's not a whole lot to remember because you just had it like 2 days ago. But for you guys, when was the last time that you guys did integration of natural logs?
Integration?
Yeah, no, I'm sorry. Derivative of natural logs.
Oh, there you go.
Been a while.
It's been like at least a month.
Okay, so the derivative of natural log of x is,
Wait, no, it has to be at least more than a month because we've been here for 4 weeks. What?
that's if it's u, but if it's a derivative of natural log of x, it's 1 over x.
It's 1
Right?
over
So
x.
if you take the derivative with respect to x of natural log of u, that's u prime over u. But the easier way to think about that is if I've got
Oh, so the first one.
y equals natural log of u, and you're going to take the derivative with respect to x. So this would be dy over dx equals, well, the derivative of this one would be 1 over u, but if you multiply both sides. So if you, it depends what you'd like. So that it's the same. Okay, that's what you've been doing. So no problem there. So just remember that the natural log of x is 1 over x, and you're going to be in good shape. So you might. So if you integrate, it's going to go the opposite direction. So if I integrate 1 over x, I get natural log plus c. Same thing here. So if I take the integral of 1 over u, obviously I'm going to get natural log of u. Add c, unless it's definite, and then you can plug this in.
So these are always going to have ln. But
Or you might have to use u substitutions to get you an ln. Right? The thing to remember on these is it's not every time you don't want to do this every time you have a fraction. That's not the point. So like if I have the integral of 1 over x squared, you have a better way to do that. You're not going to use natural logs for that. If I have the integral of 1 over x squared dx, what do you do for that?
it's just brings the top so it's
Yeah,
negative.
you do a rewrite so that you would have x to the negative 2, take the integral of that, so this would be x to the negative 1 over negative 1 plus c. All right, got that? Now, the problem, why can't I do that with the integral of 1 over x dx? Because I'd have x to the negative first, and then I'd have to raise that up one. I'd get x to the 0. That's a problem,
Times 0.
which is 1 over 0. Oh, no.
That doesn't work.
Yeah, that's a problem. So we need something else for that one. So
So it's only
it's
when
not every time you have a fraction.
Only when
It's
it's an x.
only when it's an x to the first in the denominator.
Alright.
Okay. So you might have to do some u substitutions in order to make that happen. How about this one? How can I rewrite this to make it easier for us? What's happening here?
It's just 2 times 1 over x.
So it's coefficient. So the 2 can go out in front, and now I've got this, and now I've got 2 times the integral of 1 over x is natural log of x. Oh, you can also rewrite that as,
You run out of paper yet? Do you need-
No, I got this.
Rude. I'm not striving for.
okay, here's a good example. So on this one, I do have a 1 over some stuff, right? So I don't know how to integrate that, but what can I let
You substitute.
u be? 4x minus 1. Now, that means that du is going to equal 4 dx. All right, so when I make my substitution, I'm going to have 1 over u. When I put du in here, that takes care of the dx.
1/4.
So I got to throw a 1/4 out in front to compensate for the 4 that I put in. So now I get 1/4 natural log of u
Good morning,
plus
Stowe High
c.
School.
Back
It's
substitute,
Wednesday,
1/4
February
natural
20th,
log of
And these are your daily announcements.
4x
We're
minus
going to start
1.
out today with today's Black History Fact.
What's the last thing that now I'm good with this. You could also rewrite this as natural log of 4x minus 1 to the 1/4, or natural log of the 4th root of 4x minus 1. All of these are the same.
Thank you very
Can you
much.
write this?
And on to the rest of our
Because I
announcements.
know I got. That's right. Yeah, you're an evil villain. Scrub.
Good at it. All right, the area of the region bounded by the graph, well, that's integral. And we're trying to tenon in by the x-axis and the line x equals 3. I think I really wanted this to say y, so maybe I did make mistakes. So that we're putting it in here. So when I take the integral of this, what am I really doing?
Definite between 3 and 0.
Between 0 and 3. Between dx. All right, so we go, what's u going to be?
X squared plus 1. Add a 1, or a 1/2 to the front.
So I've got the integral of 1 over u du, and the du takes care of the x, and the dx introduced to 2, so I got to compensate. All right, so I got 1/2 times the integral of that, which is natural log of u. And I almost wrote plus c, but this one's a definite one, so I got to plug the u back in, which is really x squared plus 1. So 1/2 natural log of x squared plus 1. All right, and then we have to evaluate that from 0 to 3. Well, it might even be easier if I put this back where it belongs. This is natural log of x squared plus 1, and that's going to be the square root of that. So now it's not so bad to plug things into. When I plug 3 in here, I'm going to get, was it from 3 or was it?
Yeah, it's
Two.
Probably should.
Yeah, it probably should have been 2.
No.
No, that wouldn't have helped either.
It should have been cubed.
Also not helping.
It should have been cubed.
It shouldn't have been.
No.
All right, well, when I plug this one in here, I guess it's really not going to matter. It's just going to end up being a decimal answer anyway. So when I plug my 3 in here, 3 squared is 9 plus 1, that's 10. So I'm going to natural log of radical 10 minus, when I plug 0 in here,
Square root of 1.
which is 1. What is natural log of 1?
E. 4. 7.
0. So I really just end up with natural log of radical
We're
10.
gonna just start throwing numbers.
It's just going to be some decimal.
Well, after E and 1, I ran out of guesses. Just kidding.
Okay.
We should still cut it into fourths. And then
These are,
just to make, or just to not make fun of it.
these problems, they work out nice. So recognizing quotient forms of the log rule, it's basically, you just don't change your plan. Stick to the plan, and usually things work out pretty good for you. So for example, on this one, wow, that's kind of complicated. So I'd still use a u substitution. What are you going to let it be?
X cubed plus X, and it's nothing.
And that's very convenient, because if u is x cubed plus x, du is going to equal 3x squared plus 1 dx, which takes care of all the rest of this. So I'm really just dealing with 1 over u du. So when we integrate that, natural log of u plus c, but u is actually x cubed plus x, so natural log of x cubed plus x plus c.
Damn.
Right? Same idea on this one. What's u going to be?
Tangent.
Because du is
Secant squared X.
secant squared of x dx. So this is really 1 over u du, natural log of u plus c, natural log of tangent plus c.
Oh, x squared plus 2x. Then you add
No, you can just, oh yeah.
well, that's 2u up there.
Oh.
Or half u, yes.
So I really did get this, but I've introduced 2 that wasn't there before. So just have a 1/2 out in front. Now it's 1 over u du. 1/2 natural log of u plus c, which is 1/2 natural log of x squared plus 2x. And you can put that as a square root if you really want to, but good either way. All right. How about this?
Let's see. We're getting close to it. It's gonna be 3 when you get it off the front.
Not really. Mm.
Oh, these are creative methods.
How do you, what do you call that?
Yeah, the top.
Make the top two different things.
Doesn't
Yeah.
factor.
Oh, okay, then don't do that.
Yeah, that's out.
Just kind of crumple a piece of paper up it and just throw it at it.
Also, not an option. Getting up, not an option. I'll just head that one off at the pass.
Just erase it.
Just see what happens.
It's kind of like getting up.
You can take out a 1.
Just try this. Just do u as x squared plus 1. See what happens.
Ooh, I don't like that. Oh, that's true. You can just kind of tell them. Yeah, I don't like that. Oh wait, but you can solve. Wait, no, you can just do x squared plus 1 plus x and just do and put a 2 out. And does that work?
Split it up.
Oh, that's
All right, need a hint?
Split it up.
no.
I want to
Yeah.
keep guessing.
Sure factoring out a 1.
You
is
can't
not
split
gonna
it up. X squared over x squared plus 1 plus x squared over 1 and the x
Oh
squared
yeah,
is going to cancel.
yeah. You like split the fraction up.
No, they won't cancel because the plus 1's still going to be on the bottom.
No, but it doesn't matter. We can split the fraction up and then have the u on the top and u on the bottom. Or
So you want to go?
like x squared plus 1.
Yeah, but you can't cancel it.
Oh, can't you keep the plus 1 on with the x squared?
This is all one piece. It has to
No,
go.
on the top. Like here. Let me see if you can.
Oh, you mean split it up into 2 things?
Yeah, like here.
And then the one of them's just 1.
Oh, that's.
That is not what the laser does.
Eraser doesn't draw, silly.
Somebody put chalk in it.
Oh, now it's red.
I don't think you can do this.
Alright, plus.
I
Oh,
think
wait.
That's illegal. Breaking the law, Dag.
Yeah, you can do that, can't you?
Breaking the law. So that's just 1 plus.
And then, so then u equals. Oh.
Oh, don't even do u.
Yeah,
Make that
it's
whole thing
technically
1
the same
first.
thing. Yes.
No, I know, but no, but this might. Well, I guess yeah, you could probably.
Cross that whole thing out
Alright.
and make it plus 1.
So then this. So then du equals 2x.
Then you just need to throw 1.
And so then you get the 1 half. God, this is annoying. How do you do this? Of what is this? So this is
So x is going to cancel.
1. Oh,
Yeah, 1 over u dx, and that's plus 1. So you're going to have to solve for 1.
I got it. All right, then so it's 1 over
No, you screwed something up there.
d. Or oh wait, no, it's not du. It's u. U, right?
But it's 1 plus.
No.
1 plus 1 over u.
Here's what happens.
Oh yeah.
This didn't
Cancels
go
out,
away.
It's just plus 1 over here. Now that cancels out. So what you're going to need to do is solve for 1 probably. Right?
No, it would just get broken up. So what he did was okay, actually.
Shabam.
So it's just 1 over 1
Yeah,
half.
this isn't the route that I was going to take, but this
1 over
will work.
u du.
Where'd the 1 go?
Oh, plus 1.
It's still plus 1. And now you can break it up so that they all. And then
So they
this
get
is
their own
all-
integrals, and the integral of 1 is something.
Wow, my fingers are too fat.
That's
There,
good enough.
That's a
That's
parentheses.
what that is.
Yeah.
All right.
And then each one of those would get their own.
Get their own 1 half too, though, right? Do 1 half.
Yes.
That's just 1 half on the outside.
Right. A big 1 half.
Yes.
Yeah.
Do it, Daggy.
Oh,
Top it off.
can I?
Hey, where do you stand when you do this? How's that?
Yeah,
Your
how's
shadow's
that?
always in the way.
All right. Well, if you stand over here, it works. All right. So then you got 1 half.
They can't see the shadow.
Yeah. Sorry. Who listens to this? Really?
1 over u, and then integral of 1 plus.
And one, and then du, right?
Yeah.
And then integral of
Plus.
1, or just du. Is it plus? Yeah.
Plus right there.
And your
Alright.
parentheses.
So then
1 half ln of u. Parentheses. Throw parentheses. Ln of u.
um
And then it's plus. I don't know what that becomes, but
It's 1.
just one.
No, it would actually be.
U.
0. Nothing. It would be nothing.
Yeah.
It's just gone.
Now I know why I didn't go this route. Well, is it going to be a U or is it going to be a?
Well, if you go backwards, it'd be a U, wouldn't it?
I feel like it doesn't get that part of it.
So it'd just be
You
gone.
did your substitution after U.
Shouldn't it be plus 1 du, and then it's just
Yeah,
U?
which is, I mean, the one's implied.
Yeah, well then it's just U, right? Because it's
Yeah, well,
one.
if you're still doing the U, but I feel like you did the substitution for the U after you had already done the simplifying. So I feel like it should really be X.
I don't know.
Yeah, that's why I would stay away from that.
Alright.
It's all about when you do your substitution. I think it may still come out to be the same. I don't want to erase this because I think it might still be right. Let me just clone this
Just
and
do it correctly.
take it with us. What I had envisioned for this one was long division.
Oh.
Okay, so
Yeah,
x
I'm glad we
squared
didn't
plus
do that.
1 goes into x squared plus x plus 1 multiplied by,
Ours was much easier. Definitely.
1.
Yeah, it's just 1.
Yeah.
And then you got x plus 1, and then
1.
you can't do anything.
so over x squared plus 1. So if I look at it being like that, then I've got a 1 plus x over x squared plus 1, which is what you guys had. Yeah, so you're okay. The difference here is I haven't done my u substitution yet. Okay, so follow where I'm coming from. See how this is the same as what you guys had
Yeah.
here so far? Okay, so you got the same thing. I have not done a u substitution yet. I'm breaking this up. I'm still in with everything's still dx's. So this is integral of 1 dx plus the integral of x over x squared plus 1 dx. I still have not done a u substitution.
Oh, okay.
What's this?
That's
1.
1.
X.
X plus, can't do that one. So now I've got this little mini problem within my problem where that requires the u substitution. So back up here where you guys were, this is not natural log of u plus u, this is still x. But you guys kind of lost that part of it because you did the u substitution but was still carrying it.
So I like
If
the way
you
we
don't let
started.
that be x, then you're all of a sudden you've got more stuff in there because you got to substitute this x squared plus 1 in for that, and it doesn't belong in x squared plus 1. It's really an x. Does kind of make sense?
I like
So-
how I started it though, and then
Yeah, I kind of like that too. Like I said, that's not the way I thought about it first. My first initial, because I've done a lot of these, was to long divide it first.
well, yeah, I've never thought to long divide like. That's not
Although your
something that
your
can-
initial response was perfect. Like you should look to factor it and then cancel first. If that fails, then you got to be more creative. Yeah, I like how you did that. Just be careful. Like when you broke this up,
Yeah,
you should have left
the du out there, or the
here. We should have left this still stay before it got broken up, and then I think you would have been okay. This never should have been wrapped up with u's
Yeah.
ever.
All right.
Okay, so now we're back. So this is actually going to work out okay. So I get 1/2 natural log of u was, I forget already, x squared plus 1 plus x. And each one of these gets the 1/2. But this is good the way it is. Good. And this is this is going to end up yielding that as well. How about that?
That's where I'm log thing.
That's what. Yep. Boil it.
X squared plus 2x plus 1.
So it's just 1 over x squared plus 1. Oh no, not what I was thinking. I was thinking cancel the.
Yeah,
Oh,
so
you
I'm gonna
can't.
have to have
You can't do that. Yeah. Just kidding.
a 1/2.
Yeah. Yeah, that's right. Yeah, I was thinking cancel the 2x, but you can't do that.
No, that's a problem. That didn't work out the way that I thought it was going to.
Well, no, that doesn't.
So,
Say this
what else?
problem's broken.
You could just say u to x plus 1 and then solve for 2 of x. And then it would be like u minus 1 be 2 parentheses u minus 1.
I think this problem's broken. You should fix it. Take it back to the shop, return it.
Let me try real quick.
What if we just let the bottom be du on its own? Or I'm sorry, let the bottom be u and have to chain roll it.
X plus 1 squared for you? Or just x plus 1?
Let's let
I squared
u equal x plus 1.
Yeah, it's plus
So du would equal 1. So dx. So I didn't really get any help there, but I now have this as being a u squared down in the bottom. And when I use my du, that still does take the place of u, but now this needs a fix. So now I'm looking here.
It's going to be 2 times 20 u minus 1.
U minus 1 equals x. So 2x is going to be twice that. Okay, so this is going in here, which isn't bad. It's always better to have more terms in the top than the bottom.
Split literally.
So break it up.
Could you pull 2 out? Just make it 1 before you split it.
Sure. So those
Yeah,
go.
I was gonna do it beforehand.
This goes out in front.
Because both of them have a 2, so it's just
Now be careful. I'm going to get 2 times what is this
that's that one.
plus what is this.
So it's 2. No, because it's negative
Oh, negative.
u to the 1 negative first.
Mhm. That's not right.
Yeah, negative first.
U over negative 1, negative
Yeah.
1.
There you go.
Plus c, and then we got to do some fix. So 2 natural log of u plus, it's actually going to be minus 2 over u.
Yeah.
Plus c. And then we can put the u back in, which was x plus 1. So this will be natural log of x plus 1 squared minus 2 over x plus 1 plus c. Where'd this come from?
From the 2 that came up, yeah. Alright.
Kind of.
Yep.
Alright, so you might have to be a little creative with some of them. Don't be afraid to long divide, especially if this power, the higher power is, if the higher power is in the top, you almost have to long divide at that point. So don't be afraid to go that route. I don't know if that's right or not. I guess it was. So page 338, 1 through 23 on.
Yeah.